thank you for joining me again. And now what we're going to be talking about is arc length. And so what we're going to have is we're going to find the arc length of the function f of x equals 2/3 x plus 1 to the 3/2 on the interval 0 to 3. So now, again, the first thing I'm going to do is I'm going to graph this. I've graphed the function f of x equals 2/3 x plus 1 to the 3/2. And since we want to find the arc length, what we're trying to find is the total distance we'd have to walk to cover moving along this from x equals 0 to x equals 3. In order to find that arc length, we're going to do what we have been doing is we're going to cut out cross sections and then add up the lengths, in this case, of the cross sections to get the total length. And so if I cut a cross section, what we're going to get is something that looks like that. Now, what is that is just a line that moves from here to here and here to here along the path given by the function. So now, what is the length of the cross section? It is going to be, well now if we look at this, notice that there is a change in the x direction and there is a change in the y direction. Therefore, we can't just say that it's delta x because that's not a good enough approximation even if we let delta x get infinitesimally small. We also can't just say it's delta y. But what we can do is we can notice that, well, if we approximate this using linear functions, then eventually those will be good enough to give us a good approximation of what the function is going to look like. So if I let my changes get infinitesimally small, I'll get an exact value. Now, in order to find this linear length, we notice that we have a right triangle. And so the right triangle is going to follow the Pythagorean theorem. And so what we get is that this side is going to be this side squared plus this side squared, take the square root. So I get the length is going to be the square root of delta x squared plus delta y squared. Now, in order to help us with some calculations, we're just going to simplify this. On the inside, I'm going to divide and multiply by delta x squared. So I get, if I divide by delta x squared, I get 1 plus delta y over delta x squared, this whole thing, times delta x squared. And now because I have a square root of a product, I can take the product of the square roots. So what I end up with is the square root of 1 plus delta y over delta x squared times the square root of delta x squared is just delta x. Therefore, the length of my cross section is going to be the square root of 1 plus delta y over delta x squared times delta x. Now, if we're going to find the entire arc length, what we have to do is we have to add all of these up as these changes get infinitesimally small. So what we do here is we would say that the entire arc length, or the length total, is going to be the integral from a to b of the length of the cross sections is the square root of 1 plus. And now, because these are getting infinitesimally small, it's going to be dy dx squared times dx. Now, if I look at that, I just want to note that dy dx is just the derivative of y with respect to x. So what I want to do is I want to find that derivative so that I can then calculate this integral. I'm also going to have to find my starting value and my ending value in order to figure out what this is. Therefore, if I look at this function, if I want to find dy dx, I would take the derivative. So if I take the derivative of 2/3 x plus 1 to the 3/2, notice here that in order to do this, I'm going to use a chain rule. My inside function is x plus 1. My outside function is 2/3 I to the 3/2. So the derivative of the outside is 2/3 times 3/2 is 1, times the inside to the 3/2 minus 1 is 1/2, times the derivative of the inside is 1, so my dy dx is just x plus 1 to the 1/2. So now if I plug that in here, what I'm going to get is the integral of the square root of 1 plus x plus 1 to the 1/2 squared dx. And now the last thing I'll need to do is to find a and b, but those are given to me because I'm integrating over the interval 0 to 3. So I'm going to integrate from 0 to 3 the square root of 1 plus x plus 1 to the 1/2 squared dx. Or if you prefer, we could say this is the integral from 0 to 3 of the square root of 1 plus x plus 1 dx, or the integral from 0 to 3 of the square root of 2 plus x dx. Now again, I'll let you go ahead and go through that integral on your own. We have a couple examples previously if you want to go back and check those videos. But we have now set up the arc length. We found our cross sections, the length of each cross section. We've added them all up in order to find the total length or arc length of my function. Alright, thank you for joining me for calculus practice. If you'd like to see more problems, you can check out the rest of this playlist available up here. Also, please sure to subscribe to the channel so you can see when we have more of these coming up. In addition to that, you can also check out the link available in the description below to see the written version of each of these problems so that you can pull that up to follow along with the video or to do on your own for extra practice. Thank you and good luck with your studying.